Welcome to our mechanism description group project video. For our mechanism description, we chose a camera's iris diaphragm. This small circular mechanism can expand and contract a hole at its center, known as the aperture. The iris is one of several mechanisms that help control the exposure, or how much light reaches the camera's receiver. The iris also helps focus light, which determines the depth of field of an image, or how far away an image can be in focus. This mechanism has thin, small blades that are held together with pins and an outer ring. When a dial on a camera lens is turned, the blades expand or contract, allowing more or less light in, respectively, modifying the exposure and focus.
Suppose you want to take a picture of your dog in front of Brookings Hall at noon. Completely opening the iris maximizes the amount of light entering, producing a bright, washed-out image. Lights from objects close to the camera, like the dog, hit the receiver in a straighter path, so the object is in focus. However, light from objects farther away hit the receiver at more angles, so they are blurry. Closing the iris halfway reduces how much light enters, so the image is darker. By reducing the size of the aperture, there are now fewer angles at which light can enter, bringing objects farther away into focus. Closing the iris entirely lets little light in, producing a darker image. This focuses the light best though, so the entire setting is in focus.
This mechanism has four main components, each made of plastic. First, we have the blades, small, thin, triangular-shaped pieces. This shape allows them to fit snugly in a circular pattern and slide along next to each other when assembled. The purpose of these blades is to create an opaque barrier against light and vary the size of the aperture. A small pin is inserted into each blade, which interacts with two plates and guides the motion of the blades. Although it may appear they follow a spiraling motions, the blades actually move in straight line paths.
Next, we have the two outer plates, the base plate in green and the drive plate in orange. The base remains stationary while the drive rotates. Slots are cut into each to guide the pins attached to the blades to move through a predetermined path. Rotating the drive plates pushes the pins, creating the movement in the blades. The drive plate has curved slots to accommodate for its rotation. These pin paths are designed so that the blades will adjust their aperture to a range of diameters.
The next part we have are the pins, which hold everything together. These are all cylindrical in shape and fit snugly into pinholes on the face of the blades, while also sliding freely through the slots on the outer plates. The last part we have is an outer dial, which connects to the drive plate. This dial is actually built into the camera lens and is the only part that the user directly interacts with, allowing them to adjust the size of the aperture. Most modern camera apertures range from f1.4 as the largest opening to f8.0 as the smallest opening. These notches are referred to as f numbers, which in technical terms refers to the ratio of focal length to aperture diameter.
Operating a camera's iris is very easy. The dial of the mechanism is built into the outside of the lens. When you're holding the camera, simply grasp anywhere on the dial and rotate right or left. The dial can be aligned with stationary numbers on the lens, which indicate how wide the aperture is.
The iris diaphragm is a clever, versatile mechanism that has been redesigned for a variety of specifications. In some, the shape of the blades is changed so the aperture can close entirely. In others, overlapping blades with smaller cross-sections allow for a smaller diameter device. In many modern cameras, a photographer simply selects the desired aperture on a screen and a motor rotates the iris. Irises are essential optical tools used in a variety of devices, from cameras to microscopes to telescopes, but the underlying mechanism is always the same.